Okay, let's do this. Let's figure out how to use the geometric series formula to find S sub 10. That's what our goal is. We want to find S sub 10. So we want to find the sum of the first 10 terms of this series right there that's given to us. Well, step number 1 is to find the common ratio, or figure out what do you take and multiply this 3 by to get 4. You multiply it by what? Well, it's not as easy as this last one. On these, look at this. This is 2, 4, 8. That's obviously doubled. This one's not nearly as easy. So how can you figure that out? Well, here's this key thing. If you look in and you don't know, what you do is you take the second term, 45. 4.5, not 45. And you take the first term, and you take the second term, and you divide it by the first term. So what is 4.5 divided by 3.5? If you can't do that in your head, you just grab your calculator and you do it on your calculator. 4.5 divided by 3. I can't type right now. 3. There we go. And 1.5. Let's just double check that. Let's see if that works. Okay, so supposedly I did this right. It's 1.5. A common ratio is 1.5. So if I take 4.5 and I multiply it by 1.5, I should get 6.75. Let's see if that's true. Let's see if that's true. 4.5 times 1.5 equals, oh, there. Okay, so it is. That is the common ratio. Oh, we're going. This is great. Okay, so we find the common ratio. We know that R is equal to 1.5, and that's because we took the second term and divided it by the one prior to it, the first term. Hey, if you want to challenge stuff, you could take the 6.75 and divide it by that one, or you could take the 10.125 and divide by that one. That's how you figure it out. Okay. Step 2: plug in the t sub 1, or otherwise known as the first term, the n, the number of terms you have, and the r into the geometric series formula that I showed you before. Okay, so we got to figure out what these three things are. Let's hunt them down. Let's hunt them. Okay, t sub 1. Let's find that. That's the first term. Oh, here it is. I found it. So there you go. And then we put it 3 right there. So we found our first term in the series. The n. How many terms are in this series right here? Where is that? I'm looking for it. Oh, it's right here. The S sub 10. The 10 tells you how many terms are in this series. So we're going to put 10 right in for that. And the common ratio, we had to hunt that down by doing the second term divided by the first, and we found that was 1.5 right there. So we're going to plug those things into this formula. Okay, so let's do that. This is equal to t sub 1, which we found was 3 right there. So we have 3 times 1 minus our r we found was 1.5. So we got 1.5 to the n, which is 10. And then we have 1 minus 1.5. Okay. The next thing you know is simplify it down. This isn't really easily simplified. This is kind of hard to simplify. So maybe the next thing to do is simplify our calculator. Calculator. So let's just take that and put it in our calculator. That's always handy for us. So we got, and guys, you got to be careful when you're doing this. We're going to start with a 3, right? And then we got a parenthesis. This parenthesis is going to be for the top, okay? 1 minus 1.5 to the 10th power, okay? So we just did the top here. We just did kind of this thing right here, right there. The 3 times that. And then we're going to be dividing this by, oh, we got to close the parenthesis, right? Dividing this, start up another parenthesis. 1 minus 1.5. Close that parenthesis, and then push enter. Holy cow, there it is. Did I put that in right? 1 minus 1.5 to the 10th power. 1 minus 1.5. Geometric series and secret. Oh, that's as good as it gets. That's great. So our final solution to this would be equal to 339.990234. Now, that's a little excessive. How about we just stop right there at the 0.99? That looks pretty good. 339.99. You could even, hey, gosh, you could even make that 340. That seems like it's a good number. 340. So, that is how you can use this formula, the geometric series formula, to solve a problem giving a geometric series right there. How you can do that, and you can see how useful that would be if you wanted to find like the first 100 terms. Oh gosh, that would be useful. Wouldn't it? Let's see. Let's go to the next page. What are we finding out? Oh, now we're going to be able to find the sum of the geometric series given a summation notation. This thing is going to probably like blow your mind right there. Have you seen that before? I'm going to tell you all about it in the next video. That's my cliffhanger, guys. You're going to want to come back to this.